electronic engineering, and well, the presentation is called Wires Out. In some moments, you'll know why. Please. So I think you'll be able to guess what the problem is about after these 3 hints I'm about to give you. Well, the first hint is our world. Please again. So at the left we have 2 pictures. The red and blue one is a thermal picture which shows the most crowded places in the world. And the black one is a NASA picture which shows the city lights of the world. So as we can see, some places do not have electricity at all. I don't know, Cordillera of the Andes, for example. Africa is practically invisible. And some spots in Russia. Actually 1.5 billion people live without electricity. And, well, as a fact, Africa, sub-Saharan Africa, which is this red part over here, consumes the same, excluding obviously South Africa, consumes the same amount of electricity as New York City. Well, that's the first clue. The second clue is our blocks. Please again. Sometimes wiring can be a mess. These black lines, I find them ugly. It's like, I don't know, some evil clouds rape the canvas of our landscape or something like that. And doing maintenance, something like this is almost impossible. Actually, and this covers a lot of problems. For example, my grandparents, who live in Fusagasugá, have blackouts almost once per week, since, well, there are rains and storms, and, well, sometimes a tree branch falls over the wires and cuts them, and leave the whole town without electricity. So, well, that's the second clue. Wiring can be a mess. And the second clue is in our houses. Again, please. So, sometimes we want to deliver energy to some places, and we can do it without wires. And that sometimes can be risky. And, well, other times we have to deliver energy to some devices, but we need an adapter for that. And I think that's stupid. I mean, why do you need an adapter? What? No, wait. So, this info I've got here, I think it's kind of wrong. It says that in 2015, there will be around 5.8 electronic devices per person. But I don't know, I count already 6. A PC, a TV, a phone, an iPod, a tablet, and maybe a video game console. So, well, I don't know, before we continue, but before we continue, what do you think is the problem here? The water? Well, never mind. The problem is wiring, our dependence on Cooper wires, our dependence on them to transfer energy. So what do we do? Actually, the answer is around us right now. The answer, let's look over there. The answer is light. Light actually, well, travels through outer space. As we know, outer space is practically empty. So it travels without any medium. Well, the correct words for the solution is wireless power transmission using electromagnetic waves. Electromagnetic waves is the same as light. It's just a fancy word. So how do we evaluate this solution? Well, we go to the 3 same stages as I showed you before. So, our world. So, what do we do with Africa? With the Cordillera of the Andes, with Russia? I don't know if it's Russia, because that doesn't matter. What about satellites gathering energy from the sun? This is an artist's conception of how that satellite would look like. Since in space there's no atmosphere, there's no air, there's no light scattering, which is basically the expression of light, and that means more efficiency than, I don't know, a solar panel here on Earth in, I don't know, Sahara Desert. And actually, the amount of energy we could reach is practically the same as the one that reaches most of the modern power plants. Also, antennas reaching 95% transmission efficiencies have been built. That means that it's practically perfect transmission. And the transmission avoids the scattering of the atmosphere in the earth. However, the antennas must be somehow big. The receiving antenna that we will place, say, in Africa, will have, say, a diameter of 10 kilometers, which is quite a lot. They are somehow expensive and hard to maintain. You will have to send a tripulation to this haze to maintain the solar panels. But all these can be overcome with research in new materials, which is being done right now. So this is the solution to this kind of problems. New materials like graphene. Please continue. The second stage was our blocks. So why not, instead of wires, do we place, let's say, a pole which emits lasers, and these lasers will actually drive the power throughout our blocks. Basically, they are unaffected by mass of the solids. So if there is, I don't know, a tree branch which falls, there will be now a power cut in our towns. And these do not interfere with radio communication, such as your Wi-Fi or your cell phones. That'll be okay. However, this can be hazardous, that you can get burned by a laser. But the idea is to put these lasers out in a pole, like the lights in the street. So I don't think anyone is dumb enough to climb out a pole to get burned by a laser. So that's the second stage. And the third stage was our houses. In each room of our houses will be a tower to roll them all. That's the big stuff, the geek. And this here is the aerotype of the Tesla laboratory in Long Island, New York. At the back we have the Tesla Tower, actually the Working Right Tower, which, well, Tesla intended with this tower to provide energy for the whole city of New York. Well, he never succeeded. He didn't have the money. But my idea is to get this tower and make it small, so to fit in a room. So one socket per room will be enough. Okay. One socket per room will be enough to plug in our tower, and the radiation from the tower will recharge any device in our room, computer, a cell phone, a TV, whatever. So people may say, well, there may be some interference for signals with the same frequency. Actually no, because the frequency this thing handles is a lot bigger than the frequencies of radio. Why? Because we need a lot of energy, right? So, well, this is it. This is actually just a tip of the iceberg. There's a lot new world down this. And, well, no one said that, well, this has problems. I mentioned some of them, but no one said that the road to the future was smooth and easy to walk. But it's one that works to be walked. So if you want to, I don't know, keep evolving like as a kind, as a species, you have to get along with ideas like this. So what's left to say is welcome to the future, and thank you very much.